All right, let's get going. As you probably know, um, typically, whenever an instructor puts out a syllabus, it's almost antiquated by the time it gets out because things change. All right, and I've tried to map out the rest of the semester. That said, who's to say that tomorrow, you know, 10 people in this campus come down with COVID and they decide that they're going to go online or whatever, because we don't know what's going to happen. I think everybody would agree with that, okay? But I tried to map out what I'd like to do for the rest of the semester. Now, I'm not going to go over every day of this with you right now, but let's just go over at least the next couple weeks, all right? All right, I've changed this around. Rather than giving you a test on 2, 3, 4, and 5, which I thought would be too much, I decided to give you a test on 2 and 3, all right? So we've already gone over chapters 1 and 2. We did that yesterday. We're going to go over chapter 3 today. Tomorrow I'll give you a pretest. In other words, I've got the test that's going to be given on 2 and 3, and I'm going to model what I'm going to do after that. And if you decide you want to work on it, great. If you're like, no, that's okay, then don't. It's totally fine. But around 10:30 or so tomorrow, I'll go over it with you for about an hour. All right, so I'll go over every problem that's in there. Okay, and then Thursday will be a lab. Friday we will have a test on chapters 2 and 3. Now I know I said it was going to be next week, but like I said, I cut it down to just 2 chapters. I tried doing it like that. Next week we'll follow pretty much the same thing. Lecture on chapter 4 on Monday, lecture on chapter 5 on Tuesday, pretest on Wednesday, lab on Thursday, and hands-on test on Friday. That'll get us through those few chapters. Now, I talked with Evan, my counterpart in St. Louis. He is not going over these chapters, 13, 14, and 16. So, I'm going to go over them, but I'm not going to give you a hands-on test on them. Does that make sense? So I'm still going to go over them, and I'm still going to give you homework from there because it's going to make you better programmers. All right? Okay, I'm going to go over what the homework is going to be in just a minute. We're going to end up... Okay. Then in 2 weeks, and this is the last one I'll go over, is like I said, is this one right here. So we'll go over 13, we'll go over 14, we'll go over 16. I will create some kind of a worksheet in lieu of a test. And I will give that to you. And then I will go over it. And then Friday will be lab. All right? Remember that I think it's 2 or 3 weeks from tomorrow. There's no class on the 11th. All right? We do not have classes on Veterans Day here. I think that's actually a very nice thing that they do that. Wish there were a couple more days we had off, but hey, that's the way it works, okay? So in that week, again, 6, 7, notice, so it's cut down because so you lost a little bit of time in that week. All right? Then, but remember, after that, we only have 2 weeks and we're in Thanksgiving. All right? It's like 5 weeks away from Thursday or something like that. I don't know exactly. I don't care. And then when we come back, we've only got 14 days. So, it may or may not seem like it, but there's not much play in here. And I'd like us to stick to this schedule as well as possible. I'll just leave it at that. You all got a hard copy, all right? And I'm just gonna keep this tab always up on my machine, so I know every day, so you know every day what we're going over. All right. All right. So that said, now yesterday what I promised you I'd do, and I'm going to do that first thing, is I sent all of you. You've all got, yesterday already, you got this, it's called For Class 10/20/2020. All right, and I'm going to go over this with you. Now again, we're just stepping into this stuff, so if you say, I sort of get it, but I don't totally get it, that's pretty much where I think people would be. I'm not going to say you should be here, you should be there, because again, everybody learns this differently. Everybody in this room did fine in the last part of the class. You're all passing the class. That's good news, right? All right. And so now, like I said, we're going into the other parts. So let's take a look at it. And I'm going to go over both of these. I don't know why it's giving me debug logs, but it is. So So I'm going to open this. So I'm going to start. Does this look familiar? Because it's pretty much the same thing I showed you yesterday with those payroll programs. So I'm not going to go over any of the HTML because there's just a button on it. I did add an H1 tag at the top. As you can see, miles per gallon calculator. The other one says like grade test something or other, a test score accumulator, whatever it is. So I just want to go over this. I'm not going to say to you, believe me, you may or may not believe this, but I'm not pompous enough to say, you know, I wrote this, and this is probably the best way you can do it. Again, this is a way that you can do it. All right? I am struggling with my afternoon class because it's brand new content. Some of it I get, and it's like, wow, it just clicks. And other stuff I'm having problems with. So I talked to the instructor from St. Louis, Paul, and Paul's a really great guy. And I basically tried getting a hold of him, but he's harder to get a hold of. But I got a hold of him through Evan, and he said, I don't make keys because there's so many different ways of doing these problems. I get that. All right. I'm going to cut the size of this down just a little bit so you can see all of it there. All right. Hopefully you can see that okay from back there. Otherwise, you do have hard copies. Now, again, at the beginning, all I did was a very simple, very simple little thing. This was in as one file in your book because they combine the JavaScript right into the HTML file, which again is not typically the greatest of ideas. All right. So I broke it up into two files. You already saw the HTML file, so this is the JavaScript file. Again, trying to come up with a good practice of always adding ustrict at the top of every program file. All right, and again, that's how you do it. All right, now, one thing to notice here, if you take a quick look on lines 11, 12, 13, and 14, sorry about that. 11, 12, 13, and 14. If you take a quick look at those lines, you'll notice they're all constants, and you'll notice they're all in caps. Now, the old-fashioned way, so to speak, of setting up constants in any programming language was to always put the constants in capital letters. All right? Well, I did that the old-fashioned way. Would it have worked fine if it was all lowercase or mixed case? The answer is yes. I would have had to change everything in min miles, for example, from uppercase to lowercase or whatever, but it would have. I try to, in most of the work that I do, things like that, they're not going to change. So the minimum miles I'm expecting you to drive is 1. The maximum miles I'm expecting you to drive is 1,000. The minimum gallons, actually I made it 1. I guess I probably could have made it more, but it's still fine. And the maximum gallons is 100. Now, to be honest with you, I probably should have added a lot more documentation here. So, minimum miles. All right. The reason I really didn't was because I figured at least, and you may or may not agree with this, but the names that I use were pretty much reflective of what I was doing with them. So I figured, you know, that would be good enough. So this could be minimum miles driven, maximum miles driven, minimum gallons used, and finally maximum gallons used. Now, the last thing in the world, when you are working on homework, the last thing in the world I want you to be worried about is putting in a ton of comments, or especially when you're doing a test. Homework is probably a good idea, the homework in labs, to put in some comments. But when you're doing a test, sometimes test days go unbelievably fast. All right, and if that's the case, then don't worry about it. I'm not going to put that in there. You know, 5 points or 10 points are for documentation. All right, but notice in here, because this is interesting. Okay, that's me speaking, so you might not agree. But I'm going to move this up so I can put, there's the rest of the program. Now, when I first wrote this, it didn't work. And it didn't work because, guess what? I had the word const, where you see it in green there. And it was letting me set the value the first time, but then I came in and tried to change it in my program. I was trying to change a const. Now, when I talked about const yesterday, and I said it's kind of a weird type of thing because sometimes you can change it, sometimes you can't. When const is a simple variable type like we talked about yesterday, a number or a Boolean or whatever, you cannot change it. When it's a more complex data type that we'll get into in a few weeks, you can change it. All right? But changing this to let made it work. Okay? And now look at this. I use these backticks here, which makes everything gray. I didn't even realize that, but that's the editor I'm using. I have no idea with your editor, because I didn't bring this up in Visual Studio Code, if it changes that to be a different color or not. But you'll notice if I would have come in, and instead of doing that, if I would have used single quotes here, all right, you can see that goes away. All right, so that's just something that's built into the editor. I'm not saying, hey, that's something that's built in the editor. Do you like it? You probably can turn it off, to be honest with you. There's tons of settings for these editors. All right, I don't care enough. You know, that's okay for me. But I've used those, what are called those template literals, everywhere you see the gray, and everywhere that you see something that starts with a curly brace, with a $sign, then inside of curly braces, that's a variable. So this is automatically going to say, enter miles driven between 1 and 1,000. Does that make sense to everybody? And then, and this is what we're going over today. That's why I put it in here like this. This is validation. So I'm checking in there to see if you put in a number that's within range. So if you put in something that wasn't numeric, it'll be caught right here. Is not a number. If you put in something that's less than 1, it'll be caught right here. If you put in something that's greater than 1,000, it'll be right there, caught right there. Those double bars that you see there, that means or. If it's this, or if it's this, or if it's this. Those, as far as I could tell, those are our 3 error conditions, right there. Either we put in something non-numeric, which could also mean we left it blank, or we put in something alphabetic, you know, or something like that, or special characters or whatever, all right? Or we put in something that was 0 or below for the miles driven, which doesn't make any sense. Or we put in something 1,001 miles or above that doesn't make any sense. Does that make sense to all of you? Yes? No? I mean, if it doesn't, please say something. Because then we do the exact same thing with the gallons. In fact, when I got this working, I took it and copied it and put it in here and changed everywhere that I put miles, I changed it to gallons because it's the same logic. All right? So the point is, I'm stuck in this while loop until I put in something that's valid. That's what you've got to understand. I'm going to keep looping in there. For some reason, let's say my cat walked on. I don't have a cat. But if my cat walked on it or something, or my dog. All right, sometimes I wish I had a cat instead of that dog. But the point is, all right, that if somebody, or let's say that my granddaughter who's 3, kept running the program and just kept hitting a key, hitting the A key, boom, hitting the A key, and boom, it would keep stuck in that loop. So once I get to this point right here, I have put in a valid value for miles. That's what I want you to understand. Once I get into this line right here, I put in a valid value for gallons. I'd already checked for miles, so now my miles are okay, now my gallons are okay. All right, so now I can do the math. You know, in the book, and it's not a big thing, but they scrunch this together like this. You know, it's totally fine to use a little bit of white space in there. All right, if you want to scrunch it together, I don't care. But again, one thing to realize is hopefully some of this code that's in here will eventually go into your GitHub repository. That's why things like putting in some comments, etc., these are things that you never know that some kind of a boss or an IT manager who looks at your code, you never know what they're looking for. You really don't. All right? I mean, the people who work at the company that you might be applying to might be crummy programmers, and they're looking for a good one. Somebody who lays their stuff out in a good way. Maybe their people don't document. They're looking for somebody who does do some documentation. All right, etc. You just never know. All right. So once I get here, I do the math, so to speak, miles divided by gallons, and then I print out this. This is the same way they did it in the book. All right, so I'm using JavaScript right there to write HTML. All right, so it'll write miles followed by the miles figure, gallons, followed by the gallons figure, MPG, followed by the MPG. And that'll be calculated to 2 decimal places. Does all that make sense? Is there anything in there that doesn't? This is the time for you to ask. All right? And then we just write it out. I also did a console.log, again, just so you get used to seeing and hopefully using the console.log. Now I'm going to jump back in here to the HTML and I'm going to run it. Now in the book, they used 375 and 16, I believe it was. And there's what we get. Okay? And if I go into here, if I hit the F12 key, there it is in the console. All right? Does all that make sense? And you'll notice, because I'm going to run it 1 or 2 more times, but just so you see this, okay? And that is if I run it and I leave this blank, it just immediately pops back up again. If I put in something that's non-numeric, it doesn't take it. If I put in something that's 0 or below, it doesn't take it. If I put in something more than 1,000, it doesn't take it. All right? Now, there actually is I'm not going to say an error, but you could say, yeah, an error in this program, and that is this. Because what happens here is if I put in 1,000.73, it's going to work. But the thing is, since we did a parse int, it's going to throw away the 0.73. Do you understand that? So technically, it is taking a number greater than 1,000, but it's throwing away all of the decimal portion. It should take this. Oh, it didn't like that either. I'm surprised. Oh, okay. 1,000. Thank you. You're right. 1,000.1. How about that? See, it took it. And for gallons, again, 100.99. And it takes it. All right. So the program could be improved, is what I'm saying. All right. Any questions on that one? All right. With the other example, and again, just so you know, again, yesterday's lecture is out there. It was a little longer than most, so I put the whole thing into one tape. It was 1 hour and 20 minutes, but that's all out there. All right. So when we bring up the other one, which was called test scores, and let's take a look at those. Now, it's pretty much the same program, but I do want to mention a couple things. First thing is, if you look in here, notice what I did. I used math.round. That is a built-in thing available to you in JavaScript, which said, I don't want this, if you get an 89.499999 or below, you get an 84. If you get an 84.5 or above, you get an 85. So I either round up or I round down based on 0.5. Now maybe that's fair, maybe that's not fair, but that's just the way I set this up. All right. So since it's rounding, I don't want any decimal places. All right. So sometimes it almost looks like the math is wrong, but it's not. I tried it a bunch of times. All right. So again, nothing new here. Test scores program, same exact thing, so let's just concentrate on this. Now I only have 2 constants here. And again, since my minimum score and my maximum score are not going to change, I put them in capital letters. All right. Again, score 1, score 2, and score 3 have to be lets because I am conceivably changing them several times in the same program. All right. And again, you've already seen this in the last program because it's very similar. So it says enter a test score between 0 and 100. Now, the other thing too is, see this value here? That's just a default. That's the value that goes in the box. If you don't put a default value in there, nothing goes into the box. Sometimes it's kind of nice when you do a prompt like that to let the person know what they're looking for, or if they're just testing and they want to put in a bunch of defaults, they can keep hitting enter. All right. So we ask you to put in score 1. Then we validate it. If it's non-numeric, or if it's less than 0, or if it's greater than 100, we ask you to do it again. No, I'm not giving them an error here. So you can see, yeah, you're not letting the person know they did something wrong. Well, I'm taking for granted that they can read where it says enter test score between 0 and 100. Anyone can fat finger, and you get 100 and you accidentally hit one too many zeros and you put in 1,000. Anybody can do that. All right. So that, we're doing the same thing. So there's score 1, there's score 2, there's score 3. Again, I got it to work for this one. I copied it down to here. Once that one worked, I copied it down to here. And I just had to change and make sure that was score 1 here, 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 here. Everywhere I'm using it. Then down in here. Score 2. Everywhere in there. Then here. Everywhere in here. Score 3. All right. Then what are we doing? I did it a little different than they did it in the book. I added them up here. In the book, if you remember, what the authors did was every single time, so in here, somewhere in here, I guess like maybe here, and here, and here, they added every time to total, which is okay. But I only am adding it once. So I have 2 less lines of code than they had there in the book. All right, so the total is just the first score plus the second score plus the third score. All right, then the average, again, parse int. I want a whole number, but I want you to do the math right there. So it does this first, then it rounds the answer to 0 decimal places, and it takes that and it puts it into average. Then it writes this out. All right, and again, I did a console.log in here also. So if I run this one, and when you're running this, when you first, when you're doing any kind of program and you're running it the first time or two, put in simple stuff. Don't put in like 87.68, 35.37. Why do that? In fact, if I'm going to run this for the first time, I'm going to come in here and do something like this. 60, 70, 80. And there they are. That's pretty simple. All right, and I know then at least what I know, and there it is in the log. I know that it works with a simple case. Good, that's what I want. Now I can go back and I can refresh and run it again and start putting in other stuff. Also, notice in my message, in the book they just said enter test score. I'm letting you know which score you're on. So I've got here enter test score 1, the second one says enter. Why not make it as simple as possible for the person running the program? All right. I mean, I've read all sorts of stuff. Yeah, assume the person running the program is an idiot. No, that's not. You shouldn't assume stuff like that. But you should assume that you're making the program as simple for them to run as possible. Because if you do that, you're making it as hard for them to screw up as possible. So if I come in here, let's say you got better on every test. 43. 58, 89. So there's 3. I don't know if you add those 3 up, if the total is 189, but it's got to be something pretty close to there. All right. And again, as always, if I come in and I put something out of range, so -9, doesn't take it, 101, doesn't take it. And I could do that for all 3 of them, but I think you get the idea because it's the same code. All right. Now, we could have done something that we could have taken that after we figured all that stuff out and then used a big if statement or something we'll learn soon that's called a switch. All right. And we could have said that basically if your average is between 90 and 100, you get an A, 80 to 89, you get a B, 70 to 70, etc. You get the idea. We could either use whatever Rankin has, for their grade scale, or we could make up our own. Okay? But we could extend the program is what I'm saying. Now, I went through this one faster than the other one. Are there any questions on this one? Anything that doesn't make sense? All right, then I'm going to jump back into the book, and I'm going to go here into chapter 3. It's called the Essential JavaScript Statements. All right. And they're going to talk about relational operators and logical operators. So things like greater than or equal to, less than or equal to and not equal to. Things like and or, and not. All right, that's what we'll talk about in there. The if statements, we've already looked at. All right, we'll review them again. But JavaScript, like most programming languages, supports 3 types of loops. And actually, it's more than that, but we'll get into that later. They support a while loop, they support a for loop, and they support a do while loop. All right, I started writing some code yesterday, and then I forgot to, so I'm going to see if I can fix that by today. All right, and I'll send that out to you also. Then they go back and they enhance the miles per gallon program. So they make it look more like the one that we just went over. I think ours is better. And I'm not saying that because I think I'm better than them, but I think ours is a little more complete than what they had. All right. Then they have a new program that they call future value. And the idea is if I put $1,000 away a month, and let's say that I'm able to do that for 10 years, and I'm making 3% over that time, how much money will I have earned? Not just my money, but in interest, how much money would I have earned? All right. Then they get into arrays. It's 6 pages. So I'm going to very quickly go over arrays, but I don't expect you to understand them yet. I don't know. I didn't even look at your chapters 2 and 3 test. But if for some reason they put arrays in there, I might do some rewrite. I don't think you should have to go through that stuff yet because there's a whole chapter. It's like 13 or 14 that's on arrays. All right. And by that time, you'll be much more comfortable, hopefully, with them. Then finally, they go back and they look at that test score application using an array. All right, so let's jump into this stuff here. So it says conditional expressions are expressions that evaluate to either true or false. When you are working in this language, and in most programming languages, if you say if, whatever comes after the if must be in parentheses. And that is what's referred to, what's in there is a Boolean expression. It must evaluate so that the computer knows either A, it's true, or B, it's false. And it works the same way when you use a loop. We'll talk about the 3 loops in just a bit. But they have to be inside of, the loop condition has to be in parentheses, and it has to evaluate to true or false. Loops can be dangerous. If you don't make a way for the loop eventually to become false, it becomes what's called an infinite loop, and it'll run forever. Now, this doesn't affect you guys, but back in the day when I was in your shoes, I was in my early 20s, and I was getting a degree in this, we all had dumb terminals. We were all hooked up to a machine that was probably about as big as all 3 of those printers here put together, and about as high up off the ground as that. But when we got into an infinite loop, it was possible for us to bring everybody else we were connected to down. Because what would happen with an infinite loop was the system would keep trying to get more computing power. And eventually it would be taking it from other machines. All right. You always knew when it happened. So, I mean, our mantra was just you better save often type of an idea. All right. It's not a big thing anymore. And even if you get your machine locked up, typically, worst case scenario, you have to reboot. All right. So the first ones they talk about in here are the relational operators. All right. Well, notice with this, they talk in here about how you can convert things over. Number.isNaN. So what they're saying is what's in those double quotes a number? It's not. You can all tell that. Now, if it had said in there number.isNaN and in the double quotes they had 1, 2, 3, it probably would have come up as true. If you do enough reading in JavaScript, it sounds weird. I don't know why they use this terminology, but they do. In JavaScript, they use the terms truthy and falsy. And don't ask me why. They just do. Falsy is either 0 or -0 or double quote, or single quote. All right, I think null. Okay, it's basically everything else is true. So even if you have -56, that's true. All right. So as we start coming over here and looking at this stuff, here are our relational operators. Guess what? It's incomplete. if you have your book, if you have a hard copy of the book, now whether you do this or not, it's up to you because it's your book. But I'm on whatever page I'm on here, 97. I will tell you that virtually 0% of the time anymore, you almost never use those first two operators. Instead of using a double equals, you use a triple equals. And I'd like to explain the difference between them to you. And instead of using the exclamation point equals, it's exclamation point equal equal. All right? And I'm going to quickly show you the difference between them. And you might not think it's a big thing, but depending on the code that you're writing, looking at, etc., it can be a big thing. So I'm going to come in here, close a couple of these things up. And I'm going to write some code in here. This isn't going to be a complete JavaScript program. I'm just trying to show you something. So I'm going to say, let number 1 equal 5. Let number 2 equal 5. If number 1 equal number 2, I'm going to just print out quickly, I'm going to print out an alert statement. I'm going to say alert, the two are equal. Else, I'm going to print out the two are not equal. And I will tell you that will print out the two are equal. Because even though one is a string, technically this has no numerical value. All right, it's kind of like the address of this place, 755, I think we are. I don't know if we're 55 or 51, I always forget. Parr Road, all right. The 755 is not a, it's what you put in an address, but technically you wouldn't ask for the square root of the address of this place. It wouldn't make any sense to do that. All right, but this will come out and measure true because it's just looking at the actual values themselves, not at the type of values they are. This will fail because this is called the identity operator. It checks not only do they have the same value, but it also checks to make sure they are of the same type. You get the distinction between the two of them? So I will tell you that virtually, you know, and I'm just amazed, even though this book is a few years old. All right, and I don't know because we're supposedly they're coming up with a new version of this book for next year. So I don't know if they've changed that or not, but I would just make that equal, 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 and exclamation point equal, equal. All right, again, that's typically called the identity equality or the identity inequality operator because it checks the type, then it checks whether or not they're equal. All right, okay, I'm asking this question. I don't want to talk up or down to anybody. You all understand greater than or equal to, less than or equal to. Does everybody get that? You know, I say if 6 is greater than 5, that's going to be true. If 6 is less than 5, it's going to be false type of an idea. All right. You can put all that kind of stuff in conditional expressions. And typically you don't use numbers like that. You use variables that hold numbers. Okay. You already saw that in that while loop where we checked scores or where we checked, you know, miles or gallons. Okay. This is the is not a number. You can check, you can use that. I use that in the programs we just went over a couple minutes ago. Notice the caseness, little is, big N, little a, big N. You can check to see if something is not a number. You can check to see, you can put it, if you use this, you can put an exclamation point before it to negate it. So instead of saying is not a number, that would be basically saying is a number. All right. These again are all conditional expressions. So this has to, basically this has to evaluate the true or false based on what else we're doing with it. And that's what they're talking about in here. All right. Now the other thing too is they say Note, confusing the assignment operator with the equal to operator is a common programming error. It is. But if you're using the triple one, you're probably not going to have that mistake, because you're only going to be using 3 or you're going to be using 1. The only time you use 1 is when you're assigning something. Let age equal 21. Then it's a single equal sign. If in parentheses age equal 21, all right, that's checking for equality and identity. All right, then there's the logical operators. Now, it's just me, but I wish they wouldn't have put them in this order, because the right order is not, then and, then or. Not is the most restrictive. Or is the least restrictive, and is in the middle. All right? So if I said, for example, let's say that I had a Boolean variable that I called is married. Okay? And I wanted to check on it in a program. So I come in here and I write let is married equal true. Okay? Single equal sign because I'm using assignment. All right? Now, there are shortcuts in virtually every programming language. I can write this. If is married equal true. Since it's a Boolean, you do not put the word true in double quotes. Don't do that. All right? Don't put the word false unless you're checking literally for F-A-L-S-E, not for false. All right, which you probably are never going to do. Now, that'll work just fine. But there's a shortcut in virtually every programming language, and that is you can do this. In fact, I'll leave it up there. Instead of writing that, you can just write this. And again, I don't know about you, but I'll take that one because it's a lot less typing to do. All right? And I can also reverse that. So I could say if is married equal false, and the shortcut for that is if not is married. I would suggest using the second one and the fourth one all the time. All right? And not only is it less typing, it actually will process faster because it's less work for the computer to do. Now, I mentioned that the order that they put them in is not really the for lack of better words, correct order. Not is the most restrictive. Because not is it's a negator. It changes the value. Not true is the same as false. Not false is the same as true. All right? Then comes and. So imagine we had two conditions. All right? Let's say, in fact, I'm just going to show it to you like this. Let's go back and let's let number 1 equal, we'll leave it at 5, and number 2 we'll just make 17. They have no significance. That's totally fine. But if I come in here and I say this, if number 1 is less than 5, and, which is 2 ampersands, number 2 is greater than 10, we do something. I don't care what it is. Do something. Else, do something else. I don't care what it is. That's not important. All right. Well, is number 1 less than 5? No. So since number 1 is not less, since this is false, would you all agree with that? That's false. Since that's false, what JavaScript automatically does is what most programming languages do. It does what's called short-circuiting. It says the first one's false. I don't even have to check the second one. So it doesn't. Because there's no reason to do that. All right. Now, had we said this, less than or equal to, now it's true. So it has to check both of them. When you use and, both sides of both conditions on each side of the and sign have to be true. If either one is false, the whole thing is false. All right? Or only one of them has to be true. So let's get this back to what we had there. And or is two pipe signs. The pipe is shift, and then it's right above your enter key. All right? So now we still have to check both of them. Because why? Because this is not less than 5. But this one is true. Since one of them is true, we would do this. All right? Had we done this, the short circuiting would take effect and say, that one's true. I don't even have to check this one. All right? And virtually all programming languages work like that. Now, supposedly, and I don't even know how you prove this, but I guess supposedly, if you do want to check both no matter what, you just want to, you can have just a single one of these. And that's supposed to turn off the short circuiting and check them both. Either one pipe sign or one and sign. In all my years of doing this, I've never seen that in code. All right. So those are the logical operators right there. Now, if you want to change the natural order, you do nots, and then you do ands, and then you do ors. How do you get around that? You use parentheses. All right. So they've got some examples right here. Again, then they show that's the order of precedence, just what I mentioned to you. Most restrictive, least restrictive. All right. I'm not going to read this stuff to you. You can take a look at it if you're interested yourselves. The if statement we've already talked about. Again, you can have multiple conditions in here. Now you know that because you can put ands and ors and nots in there if you want to. Okay, not only that, you can do what's called nest if statements, which means you can put an if within an if. Not only that, and you've seen this already, ifs can have an else. So when we look on this example, let's pretend for a second that everything that I'm putting here in blue, all this stuff that's in blue, let's just pretend it doesn't exist. All right? And we're checking someone's age, and they're 17. Nothing happens. Does that make sense? Absolutely nothing happens. But since we do have an else in here, it's going to check, and it's going to say, if you are 17, it'll come back with an alert that says you are not old enough to vote. Now notice there's a greater than or equal to in here. That's important. Maybe you've seen this. Be honest with you probably don't care, but I don't drink. But I always notice, like if I'm at Walmart, then they'll say you cannot buy liquor or tobacco products unless you were born, in this date, in this year type of thing. All right. Well, if you just turned 18, okay, and 18's the legal age, boom, you can drink that day. Or 21, boom, you can drink that day. Technically, if you're out the day before and you're drinking and you get caught, you can get in trouble. All right? And this is from a guy who used to go into bars at 16 because nobody ever carded me. All right? Back then I did drink. All right, not drive, but I drank. Okay. You can also have else ifs. You can have as many else ifs as you want to or need to have. The else that's at the bottom in this example is not mandatory. The else is a catch-all case. So this is checking if it's not a number. This is checking if it's less than 0. This is checking if it's greater than 12. Otherwise, you do this. Guess what? That's pretty much the check that we made that I just showed you. We did the is NaN. We did for the test score, we did less than 0. And for the test score, we did greater than 100. So rather than having them as else ifs, we put them in one big condition. So you've already seen this, is what I'm telling you. Typically, you don't see it written like this. You see it written more the way that I showed you. Not because that way's better, but because it'll execute faster. All right? All right. As I mentioned, 2 ways of testing whether a Boolean is true or false. Just like I said, if is valid equal, and again, use the triple equal sign here. Not sure why they're not showing that. So if is valid equal true. Now I've said this, and maybe I haven't said it to you guys before, but I would bet that Angie's heard this before. When you are in your first year of this program, you should be trying to program for understandability. If it makes more sense to you to write it the first way, if is valid equal true, then by all means write it that way. All right, the bottom line is it correct or is it incorrect? But if it makes more sense to you to write it that way, then write it that way. I have no problem with that whatsoever. I don't like the double equals, just for the reason I told you. All right. There are 3 different types of loops, major loops, that you can use in JavaScript. The good news is for next year, they're the same 3 loops, and they work virtually exactly the same way in C# next semester. So you learn them now, and then in 3 semesters from now, I guess, when you're in the Java Android class, they work the same way in there. And they even work the same way in Node. All right, a year from now, because Node's just JavaScript anyway. All right. So the one thing to understand is when you start using loops, there's something that's known as a pretest, and there's something that's known as a post-test. So what I'm going to do is I'm going to come in here and just going to remove this stuff. And I'm going to come in and I'm going to say let LCV equal 1. And I'm going to say here while LCV is less than or equal to 10, alert LCV equals plus LCV. Again, there's other ways we can write that, I get it. Plus LCV. That is going to put 10 different alert statements on the screen. What I mean is it's going to say LCV equal 1. Then it'll go LCV equal 2. Then it'll say LCV equal 3. Do you understand what I'm saying? So this is printing the numbers from 1 to 10. Well, that's kind of a pain in the butt. I don't want 10 different alerts to make sure my program ran, so I could come in and do something like this. Let str equals, I'm just going to set it equal to nothing. All right. So I'm not, rather than the alert, I'm going to do this. I'm going to say str plus equals LCV plus, we'll just put a blank space in there. And then when we're all done, say alert str. What that's going to actually print on the screen then is 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 space, 9 space, 10, and actually with a space. Does that make sense? Taking a quick look at it? Let's break it down. This is called a pretest. What do I mean? Somebody tell me. If you have to, guess. How many times are we going to run through the loop now? Anybody want to take a guess?
10 times.
Okay, anybody want to take a different guess? Anybody want to take another guess? How about none? All right. Is LCV less than or equal to 10? It's a pretest loop, so it tests at the beginning. Since it's false to start with, it never goes through the loop. Everything that you see in between the curlies, that's what's known as the loop body. So it checks the loop condition before it goes in and tries to execute the loop body. If the condition is false initially, it never goes through the body. Does that make sense? All right. So I'm going to put it back here. Now, that's the first way. Okay? Now I'm going to come through here and I'm going to grab some code here just so I don't have to keep typing. We'll take a break in just a couple minutes. So this is the first way. That was using a while loop. So let's talk about another way you can do this. I'm going to still have my string like this. In fact, I'll keep this in here too. All right. And now I'm going to use a different kind of thing that's in here that's called a for loop. Most people like that because it's a lot less to type. I'm going to get the same answer. Let's break this down. This also is one of those pretest loops. In other words, that's never going to run. Does that now make sense to everyone that that's never going to run because it's 11? All right. In just a minute, we're going to look at the last one before the break, which is called a post-test loop. That always runs at least once. All right. But now, what are we doing here? Well, notice that we're setting our loop. LCV means loop control variable. That's what I call my loop control variable. You can call it whatever you want. This is one time it's considered permissible in programming. You'll see a lot, they'll be called XYZ, IJK, etc. But I just use LCV. All right? So, what you do in here, in fact, let's just go back to this one. So what are we doing right here? In this line of code that you see right there, we're initializing the loop control variable right there. Does that make sense? We're giving it an initial value. Then in here, we are testing the loop control variable. Then finally in here, we are, in this case, incrementing the loop control variable. If we left that statement out, the one with plus plus LCV, we'd be in an infinite loop. It would just keep printing 1, 1, 1, 1, 1, 1, because we'd never be changing the value of the loop control variable. All right. The advantage of using the for loop rather, that we just went through down here is the initialization, the test, and the changing of the loop control is all done on the same line. Well, notice we already said here, let LCV, all right, let LCV equal 1. Since it already is equal to 1, we don't have to do anything here. So what we're saying there by just putting in that semicolon, don't do any more initialization. But test it. If it's true, do this, then come back up here, do this, and then test it again. So it's doing the same stuff. All right, but this is called a counting loop, because you need to know exactly how many times you're going through it. Sometimes you don't. Maybe you're reading through a big file of records and you don't know how many are in there. You can't use a for loop for that. All right? And files typically on the end have something called an end of file marker. All right? And with that, you can't do that with a for loop. It just doesn't understand it. You'd have to use a while, or as we're going to look at in just a minute, what's called a do while. All right? So again, this is going to give you the same result. So let me grab this, because it's almost going to be the same thing. All right. Now it's going to look very similar to what we just did. However, we take this right here and we move this down to the bottom of the loop. And you have to put a semicolon there. That's a post-test. So now if I set this equal to 11, I don't check to make sure it's less than or equal to 10 until I've already gone through it once. So this is going to print out 11, and then it's going to stop. Now, many people find this loop, this one, the do while, to be very confusing. And I've heard people say, why would I ever want to use that? And that's a pretty good question, really. But sometimes you want to go in and you want to check your code in a loop. And if you know that that code that's inside of a loop is only going to happen, as the saying goes, once in a blue moon, all right, you might do it with a do while, so you put it in, and you make sure it runs at least once, and then it handles that correctly. Then you might change it back to a while. So this is a post-test loop. You are still initializing here. You're still, and really the testing, I'm wrong. The testing isn't done there. The testing is done here. All right, you can use any of those. The while loop and the do while loop you can use all the time. The for loop is a counting loop. All of them are being used as a counting loop here. But the for loop is a true counting loop. You need to know where you're starting. You need to know where you're ending. All right, it's 9:02. Let's come back. Let's make it 9:16, please. All right, and when we come back, we're just going to continue on until we finish the chapter. All right, then I'm going to continue on. So I've already hit most of the stuff in the next few pages, but I thought it'd be better to show you an example. All right. So they explain in here the syntax of the while loop, and they give you an example. Then they go through the for loop, and they give you an example. The examples aren't that different from the ones I gave you. And that brings us up to this 3 illustrative applications. What I did, if you care, I just sent you another email during the break, but I want to show you what's in it. I wrote all 3 of the loops and put them into a program. All right. So there's the while loop, there's the for loop, there's the do while loop. Since I put them into one program, I had to use different variables. This one was LCV, the next one was LCV2, the next one was LCV3. But it prints out the numbers from 1 to 10 using all 3 loops. It puts a comma between each one, except not the last one. So when I run this, again, it's nothing grand and glorious, but okay, there's the numbers 1 to 10, there's the numbers 1 to 10, and there's the numbers 1 to 10. I didn't use any console logs. It's just there. All right. So if that helps you, great. If it doesn't, no. If you throw my emails away, then you throw them away. All right. So as it says here, 3 illustrative applications. So first they've enhanced the miles per gallon program. So let's take a look at what they have in here. We're just going to concentrate again on the JavaScript. Now you'll notice they're using a do while. Now the way that I wrote the program, in the example that I showed you, you still have to run it. Once you put in valid data, you got to run it again. They did a better job than I did here because they put the whole thing in a loop. So you can run it over and over and over again. You see what I'm saying? And they used a do while. So they've got, this isn't a Boolean. They could have made it a Boolean. All right. But they used just a simple character called again that they said equal to y. All right. And they say, basically, since it's equal to y, go ahead and do this. So there's your miles, there's your gallons. Notice all they're checking is both miles and gallons are greater than 0. So they're not checking even for an NaN in here, for not a number. And you could put in a gazillion, if that's a number. But you could put in as big a number as you could handle, which probably wouldn't make a lot of sense, but it would take it. All right? So that's just another way of writing it. One thing I do want to mention, though, is if you take a look at this, notice where it says do while again equal y. See that? First of all, I'd make it 3 equals. Okay? Second of all, guess what? If you're running the program and you accidentally aren't paying attention and you put in a capital Y, it's not going to continue. But what you'll notice very soon, we start talking about strings and string methods, there's a method called toLowerCase, which will automatically take anything you put in and lowercase it. Since there's a toLowerCase, there's also a toUpperCase. All right, which will uppercase things. Okay? All right. Then this is the new one. This is that future value application. So again, I come in here and I say I'm investing $10,000. I thought they were doing it by the month, but they're not. So I'm investing $10,000 at an interest rate of 7.5% for 10 years. Good luck finding anything today that will give you a 7.5% interest rate. All right? But that's fine. So what they're saying is if you invest $10,000 for 10 years, all right, with that interest rate, at the end of time, you'll have basically doubled the amount of money you have. All right? So this is how they do it. So notice there's a lot in here, so I'm going to shrink this down just a bit. That's most of it right there. So let investment equal 0. It is always considered a good idea to never go and like right here, we could have said let investment semicolon, where the value would have been undefined. You really should get used to not doing that. In some programming languages, if you don't give a variable an initial value, one will be provided for you. This is not one of those. So you're best off doing it like they did it right here. So notice they've got 1, 2, 3 do while loops and a for loop. It's just the way they decided to do it to illustrate some of this stuff. So what they're doing here is you can put in any number as long as it's a number. So you could put a negative number in here, in what they have. So their check isn't really complete, in my opinion. All right? Then you put the same thing in for the rate. And again, you can put in a negative number for the rate. All right? Then they have a number of years. And once again, you could put in a negative number for the number of years. You probably wouldn't do that. All right? And there is a function that you can use where you could, on the next line, you could say rate equals math.abs, absolute value of rate. And then if it was a negative number, it would take away the negative sign. All right, so there's ways that you can even get around that. You could use what they have and probably make it a little better. But this is where all the stuff is taking place, so to speak, is in here. That's what's figuring out that $20,610 that they talked about. And again, they're using the template literals, so they're using the backticks, and the variable name is going right in the string itself, preceded by a $sign, and the variable name must be inside of curly braces, and if you want to, you can even, like they've done here with a to fixed, set the number of decimal places. All right. Now, it's not my goal here to go through and say, hey, this is how you do a future value. This is a way of doing it. I know Muroc, because we've used their books for lots of classes, they love this future value example. They have it in virtually every one of their books that does anything with programming. So then they enhanced the test scores application. Now they've got 4 scores, it looks like. All right. And notice they've only got one that's called score. So they do this, and you can actually, it looks like you can keep entering scores until you enter a score of -1. Now, if you're going to do that, then -1 right there is what's known as a sentinel value. Sentinel, after the old thing, like if you ever watched like a old Army movie or MASH, when you Hall 2 goes there type of an idea, it's a stop value. All right? And sometimes you'll even see that instead of writing it like they do here, -1, all right, they'll put a constant up on top that they might put in capital letters called stop, and they set it equal to -1. Then down here they could say, while score not equal to stop, which might make it a little bit easier for people to understand. But if you're going to do that, and they do a good job here, -1 to end scores. And notice they even default it to -1. All right? So in the example they have, it works just fine. And now they are checking to make sure that it's greater than or equal to 0 and it's less than or equal to 100. If it is, you are adding 1 to the score. You are incrementing your count, which is your total number of scores, by 1, and you're writing out that information. All right? And that is, in this case, that's within range. Otherwise, if it's not equal to -1, that means you put in here in this else if something that's out of range. So you either put in a negative number or you put in a number that's 101 or above. All right, so that's going to handle that. We don't want to count that into our scores, so we don't have a count plus in here. So like they do here, they put in 4 scores, 89, 99, 78, and 91. All right? Now, the way they've done this, which is totally fine, you now, once you get down to here, you don't have access to the individual scores anymore. Does that make sense to everyone? Because you're using the same variable called score every time. So if you wanted to access them, all right, not like this, but you wanted to be able to put them someplace and access them, you'd probably use something like we're going to look at in just a minute with an array. All right? Then the stuff is the same as what we looked at before, so there's nothing else new in here really. All right, so speaking of which, let's talk real quick about arrays. And again, this is meant to be a quick little introduction and not to confuse. Did you hear me? It's not meant to confuse. All right? When I first moved here, I moved here about now, I don't know what it was, around 5 years ago. The first year that I was here, I lived in an apartment by myself. My daughter was going to school in Rockford, Illinois, So my wife kept the house that we had there, and her and my one daughter lived in the house, and I had an apartment. The reason I'm telling you that is the apartment that I lived in had 8 units in it. So there was a mailbox right when you walked in, and I was right near the door, but not that one, but close to it. But when you walked in, there was one big mailbox that had 8 slots in it. The mail person could come in, put their key in the middle, because I watched her do it a couple times, open it up, and then put mail into each one of the slots. Does that make sense? That's kind of what an array is. So let's say there's 8 of you in the class. Let's say that I created an array of 8 test scores. So I would do that like this. And I'm just going to show you this. Again, don't worry about writing it down. It's not probably going to be good enough to write down or anything anyway. All right, so let me just get rid of this. Okay, so if I know that there's going to be 8 students and that's it, okay, I can say let's see, students equal, and if I want to, I can do it like that. That creates an empty array right there. All right, and then I can come in and I can put values in each one of the components, like we put mail in each one of the slots. When you work with an array in any programming language, you start counting at 0. So the first element is element 0. The second element is element 1, etc. And it has to do with the way that computers are wired up, etc. So for instance, I could come in here and say students 0, let's say I'm just going to give grades, equals 91. And I could do this. Let's just suppose that for whatever reason, every one of you got a 91 on the test. All right? I mean, normally I would put in different numbers, but I'm just, I think you get this. So, in that case, everyone got a 91. Does that make sense? Now, the other way I could do this, just so you know, is I could come in here and say let students equal, I'm trying to remember the right syntax. I'm probably going to screw this up, but we'll see it in the book in a minute, okay? I don't know if you have to use the word array or not, but we could come in here and say 91, 91, 91, 91, 91, 91, 91, and 1, 2, 3, 4, 5, 6, 7, 91. That's the other way you could do it. That's pre-populating the array. All right, and I'm going to show you in just a minute, JavaScript is bizarre because they let you do some stuff that very few other languages let you do. All right? Okay, so either one of these ways would work. So keep that in mind as we start looking through this. They define an array as an object that contains one or more things. Each thing, just like each mailbox, but in an array is called an element. Sometimes it's called an index. It just depends on the book you read. It's not really that big of a thing. All right, so they're showing you in here 2 ways that you can create an array. All right, so, and it doesn't show you the way that I've shown you, but they will. Just take my word for it. And notice, this is the first way I showed you. That creates an empty array. All right, and this is what I want to show you, because this is a little bit weird. Let's pretend for just a second, okay? Going back to this example that I just made and I showed you, I'm going to get rid of this one. No, I'm going to keep that one. I'm going to get rid of this one. Let's suppose I fat-fingered in here, and I accidentally did this. You see the difference? All right. Now I would have an array with 78 elements in it, and element 7 through element 76 would all hold the value undefined. All right. And it's weird that they let you do stuff like that, but they do. JavaScript, PHP is a little bit like this also, but JavaScript is one of the few languages that gives you this much latitude. Next semester, when you learn C#, it's totally different. C# is very regimented. If you don't do something the way that you're supposed to do it, it just isn't going to work. JavaScript does whatever it can to make it work. All right, you can look at it as either being a good thing or a bad thing. All right, I gave you my example yesterday of my friend who played guitar, and he would always say that when they were out playing in his group, if he hit a bad note or something, usually their amps were so loud that people couldn't tell anyway. But if he was playing at a coffee shop and he hit a bad note, typically everybody knew. All right, same kind of thing here. All right. So again, you can make an empty array like I showed you, and then do this. Oh, so with a single statement. So I did give it to you wrong. Let me bring that back again. You do it like this. You don't use curlies, you use brackets. So those two things do the same thing. All right. Now, arrays, this is one thing that's different. Everybody hear me? This is one thing that's different. I can use the word const here. And then I can come down here and I can say students 3. No, they didn't get a 91. They got 100. Even though it's a const, I can do that because it's not a simple data type. It's what's known as a data structure. All right. But I can't, after I've done this, I can't make it bigger now. It's only going to hold 8 things. So I can't change the size, but I can change the contents. All right. All right. Arrays work fantastically with for loops. You know, you can go, if I had a class of 500 students and somebody had inputted all the grades for me, I could go and tell it to loop through 500 times, have a counter, and have the total number of points that were accrued. When I get done, divide it by 500 and get a class average. All right. After I got done with that, I could quickly go through, and there's arrays have a sort method, so I could tell the highest grade and the lowest grade. You know, so there's a lot of stuff that we can do real quick. We're going to write a fairly complex program when we get to the array chapter. All right. Or I'll give you the program. We'll see how it works. So an array can store one or more elements. The thing that makes JavaScript unique, again, JavaScript is like this PHP is. There are not too many other languages, at least that I know, is not everything in a JavaScript array has to be the same type. So I can do this. I don't know why you would do that, but there might be an occasion that you would want to do that. All right? All right. Again, the first element in the array is element 0, and arrays have a property that's called length. So if we looked at that example that we just went over here, the length of this is still 1, 2, 3, 4, 5, 6, 7, 8. So if I ran the length property, it would say 8. Even though the elements are 0 through 7, there's still 8 of them. You know, and again, I've said this before, sometimes people groan or whatever. It's not mine. But there's an old programmer's joke. When you tell a programmer to count to 10, they go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just because they're used to doing it that way. All right? So, how to use loops to work with arrays. Again, you typically use a for loop. This will display all the numbers in an array. This will put numbers in an array. This will sum the numbers that are in an array, etc. All right. It says when you use a for loop to work with an array, you can use the counter for the loop as the index for the array. It's true. All right. There's a couple special for loops that work only with arrays or what are called collections. Arrays are basically the only collection that we'll go into in this class in any depth. All right, but there are other ones as well. And those are called the for in, all right, and the for of. Okay, now when you look at this, okay, so we've got an array right here that we're going to call, that's got totals in it. It's got 4 totals. There they are. And if we say for let I in totals, it's a little less typing. It's like saying for let I equals 0, I less than totals.length plus plus I. You can see there's less typing to do than what I just showed you. Anything you do with a for in or a for of, you can do with a regular for loop. but these were they were set up basically for this reason. So it would be a little bit easier and people would have less typing to do. As it says, the for in and for of are used to loop through the elements in an array without having to declare and increment a counter. In a for in, you declare the variable that stores the index. In a for of, you declare a variable that stores the value. It says you can also use const when you declare an array instead of a var or a let. All right? And that's fairly new. It's about since 2015 that you were able to do that. The index variable for a for in or a for loop is of type string. So notice that means that's a string and that's a string. They're not numbers. So, a lot of people don't like these. They're just used to, especially tried and true programmers that have been programming forever. Then don't use them. If they confuse you, don't use them. It's less typing and it'll probably end up running faster. But if that's not a concern, and again, we're programming now for understandability. So if it makes more sense to use the regular for loop, use the regular for loop. All right, finally, they go back and they enhance the test scores by using an array. Looks very similar to what we did before, but notice now they declare an array called scores. What this is going to do is as we read in a score, we'll put it into the array, and so we will now have access to every score that's in there, even after we put in the -1, because we're done. All right? So notice what they're doing, because it looks a little weird. It says here, basically, enter a score or -1 to quit. If the score is within range, now look what this does. Right now, there's nothing inside of it. So it'll go and it'll basically put in element 0, it'll put in the first score. Then in element 1, it'll put in the second score. In element 2, it'll put in the third score, etc. And it'll keep doing that. There's even other ways of doing it than the way they showed it here. Arrays and other collections have different properties called like push and pop that we'll get into when we get to chapter 15 or 16 or whatever it is, it's on arrays. All right? But it does end up being a little bit better program because, again, you have access. All right, you now have access to each one of those scores. All right. Okay, that's it for the chapter. Now, I got to see if I sent this to you because I honestly don't remember if I did or not. Okay. Because if I didn't, you're going to get sent something right now. So I'm going to assume I didn't. So I'm going to send you this right now. I'm going to quickly go over this with you. Okay. There it is. What I have in here are all the homeworks, all the labs, and the written tests for the rest of the semester. Okay. For the written test, you will now get basically the equivalent of Word copies. So you can do them electronically. All right? Before I've been giving you hard copies. These are the labs. They're all based off of this thing right here. It's a 48-page PDF, and these are what's in here. Now, we're not going to go over every one of these because, again, we're not going to be hitting every single chapter that's in here. All right? But you'll notice, like I said, typically less. There's nothing for chapter 1, one problem for chapter 2, 4 problems for chapter 3. All right? Some of them have 1 or 2. There's nothing for 5, etc. All right? The other thing that's going to be in here too then is the homework based off of another PDF. All right? And again, you'll notice this has 1 for chapter 1, 1 for chapter 2, 1 for chapter 3. So they're typically a little bit more complex because there's just 1 of them. I will email you in just a couple minutes. All right, in just a couple minutes, I will email you all this stuff because I've got it all. So I will email. So you'll have all that stuff. All right. Now, that's basically what I had for today. So what I'm going to do tomorrow morning, because I'm going to create it right now, is I'm going to write, like I said, a pretest for you. You want to do the pretest? Fantastic. You don't want to do it? That's your right. All right, but I will give you tomorrow from about 8:05 till around 10:15 to 10:30. I'll ask then where people are, and then we'll go over it as a class. All right? Now, after we do that, and again, going by that schedule that I showed you at the beginning, then Friday will be the hands-on test for chapters 2 and 3. Nothing specific from chapter 1. But now we've gone over 2 and we've gone over 3. Are there any questions on anything that we went over today? All right, then the rest of the period is yours.